Thank you very much. It's my honor and privilege to introduce our next speaker, our keynote speaker, Chris Wright, for whom I work, among other things. I first met Chris when we were trying to get Zen out the door in RHEL 5, or RHEL 5, as I might have said earlier. It was difficult and painful, and then we replaced it with KVM almost immediately. But it was a lot of fun, and I'm very happy to still be able to work with him and take advantage of his guidance and his enormous knowledge of the open source world. So please welcome Chris. Thanks very much.
All right, this is an experiment on multiple levels. First of which is I'm normally a bit of a pacer, so I'm going to stand here in one spot. I know, I'm challenging myself. It's a growth opportunity. The other one is each one of these slides, it'll be the first time I've ever seen them. So this is going to be amazing. I can't wait. I'm Chris Wright, and I'm here to talk about at Red Hat what we call the Open Hybrid Cloud. And I'll repeat some things you've already heard, and I've learned through my years that you got to actually repeat it 7 times, so I won't do it all 7 times at once, but repeat some things you've already heard, dig in a little bit more in terms of what those mean to us, and I think collectively what it means for this group and more broadly for the industry. So I'll start with just a reflection on what is cloud. Now, for me, I remember the first time I heard cloud, and in fact, it was with Zen and virtualization, and we were working with a now well-known public cloud provider, building their public cloud infrastructure, and there was a dialogue in the industry about cloud is just BS, like it's a marketing term that really is virtualization. And to be honest, I was kind of on that side. Over time, I think it's come to mean something quite a bit more. And I typically think of it in 2 key areas. The first area is operational efficiency. So imagine operating a cloud, and then imagine using a cloud, which is a managed service, and then the operational efficiency of using something that somebody else operates for you is sort of, well, it's infinitely efficient if you're thinking about the 0 resources you have to put in to operate that cloud. And while it's a simple concept, a managed service, the implications are pretty significant. And the way that impacts companies, businesses that are trying to figure out how they allocate their budgets to build themselves technologies that are differentiating, pretty fundamental shift in what happens within IT budgets. The flip side is the notion that you're building something is about investment and the infrastructure and all the stuff that has led IT operations groups within large-scale businesses to be considered cost centers. Maybe some would say waste of money because they're not managing it very well. The flip side is development. And in the world where companies are increasingly focused on the technology and the way they build technology to differentiate themselves, to create value for their own customers, the development experience of a cloud is actually pretty awesome. There's a lot sitting there directly accessible to developers, and it's an API. Some identity management, a little bit of a learning curve, but the experience of either downloading it and figuring out how it runs, configuring it, operating it yourself, or convincing your own internal IT operations organization to run this thing on your behalf disappears. And when you combine those 2 things, the operational experience and the developer experience, you have a really pretty fundamental shift in how people consume technology and then leverage that technology to change their business. Elasticity is important. I think it's kind of the illusion of infinite capacity is something that's valuable for certainly bursty workloads or workloads where you really have no idea what capacity you need to support that workload. And as we talked a little bit earlier today about data and data distribution and distributing compute to data, the notion of elasticity, I think, might change a little bit over time when we look at distributed computing more broadly than centralized clouds. So the two key characteristics, I think, are the operational efficiency and the developer experience, developer velocity. How can you help developers go as quickly as possible? The data center itself, the way we build applications, kind of the world is changing. No surprises there. And I think it's changing in a couple of areas. I've highlighted three here. One I call the economics of modern applications, or how you build applications today. The other is the notion of the data center, distributing the data center. And the third is hardware. Hardware is changing. You saw the FPGA call-outs earlier today, and the bump in the wire that Oran mentioned. I mean, these become pretty normal parts of data centers today. Pretty significant change. In fact, what I would say in the context of cloud is cloud, for the first at least half decade, if not full 10 years of its existence, was an absolute lie. And the focus of the lie was on convincing you that all compute cycles are equal. And if you go to a cloud today, you'll find over 100 machine types or instance types, or pick the language of the cloud, each of which really represents some specialization and leveraging some form of hardware to accelerate a certain type of workload. So the notion that all compute cycles are created equal is naive at best, maybe even intentionally false. And the world is really starting to embrace that as a really critical way to build infrastructure. So if you look at the economics of modern applications, first you see the enterprise, which is Red Hat's world is driven by interfacing with enterprise customers. Enterprise customers have complexity. They've got all these physical data centers. They're trying to figure out how do you do consolidation. Long tail of legacy of applications. Usually an enterprise has, say, 2,500 applications that they're using to run their business, some mixture of procured and built in-house, and a spectrum of how old they are. One person I was talking to described the data center as a place that's beautiful for a software archaeologist to go in and discover every ISV component that's ever been delivered into the world. And I can tell you from my experience talking to enterprise customers, certainly the large ones, it's true. They have one of everything, if not two in some cases. Contrast that with a modern company, a cloud-native company. The cloud-native company is born in the cloud. They're leveraging that operational efficiency, that developer velocity. The way I describe it is you'd have to be completely insane to go to your favorite VC and say, I have this amazing idea, but hold that thought. I actually need $10 million to go build a data center. Like, that just isn't how it works today. You create ideas, you find the right market fit with those ideas as you're experimenting in the cloud without having to make that upfront capital investment. It's a really different way of building technology and addressing opportunities in the market. And what's interesting there is it starts off really well. I mean, you don't have legacy, you don't have CapEx to die under, but then you look at some of the IPOs over the last 3 or 4 years, and typically in their filings, they list a set of risks, and one of those risks they identify as the cost that they have to spend on cloud providers. So I think Slack committed $50 million a year for 5 years to AWS. Lyft was a little larger commitment, more like $100 million a year for 3 or 4 years to AWS as well. And then Snap committed $2 billion, $500 million a year for 4 years to Google. And these are commitments. These are, even if we don't consume that much, we have to spend that much. And you think about, those are big numbers. Those are material numbers. Most IT budgets would kill for that. And so there's a discussion around repatriation and what is the real cost benefit of leveraging those managed services and that developer velocity. I mean, it's an interesting way to look at how applications are built. Certainly, I'm biased. We spend a lot of our time building technology that supports a hybrid cloud model that allows you to take advantage of public clouds where that's the right thing and build things internally in your private data centers where that's the right thing. So some of these numbers are leaning in that direction, but I think it's useful information to think about the context of where we are today. And having talked about data, I think data is certainly driving a lot of the value that our customers are building for their own businesses. So creating insights or giving better experiences to their end customers that is personalized and giving you this sense of you're understood. The banks have something called KYC, Know Your Customer. It's about understanding the customer and engaging with them in a way that creates a sticky application or even a delightful experience for the user, which is a way to differentiate yourselves. As we have more data, more devices generating more data, the data gravity and data governance and provenance and policy compliance for location of data becomes a really critical part of how you solve deriving value from data. And it clearly is pushing us out to a world that includes not just centralized data centers and centralized clouds, but edge computing. And it's not just a buzzword, it's a way to deal with large amounts of data, which at one point, it was sort of asymmetric, a lot of, especially from the consumer side, a lot of downloading videos. But now it's going both ways. Sensors increasingly themselves are cameras. And there are different ways to create information out of sensors. And an example was in a refrigerator in a convenience store, you could have a temperature sensor, a humidity sensor, weight sensors on shelves. That will give you a sense of what's in the refrigerator. You could also just put a video camera and use machine learning models to check humidity by the condensation on the windows and do things that you could call crafty or even creepy about understanding who's reaching in to purchase certain types of drinks and market appropriately and put them at the right height and all this stuff, which is not going to happen with a cheap sensor that's just giving you temperature or humidity or weight on the shelf, but it's video driven, and you can kind of take that picture and extend it out across a lot of different use cases. So there's a much more symmetric flow of information across the network, which suggests we need to push computing closer to where a lot of the data is being created. Who's familiar with Dennard scaling? Okay, thankfully. Last time I had this slide, I got 3 people in the audience, and it was a larger audience. So the notion that hardware is changing isn't a surprise to any of you. The physical limitations that we're starting to hit up against in terms of how much power is concentrated in a small physical space, and the fab form factors, we're really starting to hit limits. You haven't seen much gain in CPU speeds in quite some time. It's really been core counts. And today, as I mentioned earlier, those machine types are taking advantage of GPUs and FPGAs and ASICs in certain scenarios, different types of storage, different types of memory, different types of connectivity to the network. So this notion of heterogeneous computing that's driven by the ability to continue to accelerate what I would call mission-critical applications for businesses that are taking advantage of these hardware features is the only way to continue to grow the performance characteristics of data centers or infrastructure. So it's a really important part. I'm an operating system geek, so that makes me excited because hardware enablement is a big part of what an operating system does. And then it creates a whole set of interesting challenges when you talk about distributed computing and scheduling and resource-aware scheduling. These are things that are the way the industry has cycles of centralization, decentralization. There's cycles in academia. If you look at distributed systems and schedulers, I don't think we'll ever finish researching those things. And so this is a great opportunity for us to work together to really push the state of the art and what it means to build infrastructure. So I think that's exciting. Now, if you contrast open source as a traditional model, which has built all of the public clouds that exist. There is a tremendous amount of open source that's under the hood in any public cloud. If you contrast open source, as we know and love it, with what you get from a public cloud experience, which is leveraging open source. On the open source side, you have code, you've got a way to collaborate, you have democratized access, and then it's an exercise left for the reader to figure out how to make it applicable to your world. And that's a world that we've been in for decades, not just only with open source software in general. And that notion that Hugh talked about earlier about the operational experience and really what's behind that is something that's driven the value in public clouds. And the operational experience derived from open source software becomes this proprietary yet critical veneer around open source software that on the one side you could say, well, this is a fundamental threat to this development model that we have, and it's changing some of the economics, and you see some of the companies that are really focused on single technologies trying to change their licenses to make them non-open source licenses to compete with the large cloud providers. But I think it just opens a question of how do we continue to build that collaborative model that advances the technical state of the art when it's not only about the source code, the features and functionality, but it's about how you operate the software, which drives us towards this operate first principle that Hugh mentioned earlier today. I think it's, from my point of view, having done some work in autonomic systems, the holy grail is software that just runs itself. And I know we're not going to get there anytime soon. We'll have people involved for the foreseeable future. But driving in that direction and trying to create collaborative work that supports that direction is really what I'm interested in. And as some of the earlier conversations that Ron and I had when the MOC was being created, like what could we do together? Well, it starts with data. How much data can we take out of these distributed systems? And then what kind of models can we develop associated with that data to give us better and better understanding of how to operate these systems so that we get to the point where we have an autonomous system. And repeating that across the software industry or across open source projects is what I would call a goal for Operate First, or building this large community around understanding how software operates. I think one important part of doing that is an ecosystem you have to have some technology that you're focused on. And one of the struggles we've had over the last couple of years is what would we be building together? Simple automation is important, but it's necessary but not sufficient. And then you have a choice. There's Chef and Puppet and Salt and Ansible and all these different tools. And so while they're important, they're insufficient. We've been focused at Red Hat on a technology layer that's broader than just Red Hat that we call operators. And operators create a framework that allow us to take more, I'll call it intelligence, in the automation of running software. And again, since it's broader than just Red Hat, it creates the potential for a bigger industry movement. And that's the kind of thing that we need. We need code, and the code needs to sit in the open source project alongside the portion of code that's delivering features and functionality, and that code that's doing the operation, that's encoding the intelligence of an SRE in source code is exactly what we need to get to for open source projects. I think it's totally plausible, and when we get to the broader industry of businesses that are trying to deliver services, they're going to care about this as well, and we've already seen uptake in the usage of technology like operators or other forms of automation. So I get some early indicators that this is going to be really beneficial and a way to drive community activity. The notion, and Hugh touched on this already, but the notion of running services at scale is quite different from running a small service. And in fact, if you look at large public clouds, many of the things that they've done in their operationalization of software includes some architectural changes to the software itself. So we need to be able to capture that and understand that so it's not just trapped in a single proprietary delivery vehicle. And then when you look at how do developers get access to the environment that gives you the ability to experiment at that scale, well, that's the other challenge. So Hugh talked about the folks in the basement. Early days in Linux, we actually collaborated across the industry. We built labs that were focused on giving large-scale SMP boxes, so this is like scale up, not scale out, large-scale SMP boxes to developers who never had those in their basements. You know, I was one of those people who had maybe a 2 CPU system in my basement, not a 4096 CPU system in my basement. And in fact, my house wasn't even wired for a system like that. So centralizing that is critical. And MOC, as an example, is an opportunity to share broader scale infrastructure and start building not just the code that encapsulates the intelligence of an SRE, but also creates the experience. What does it mean to operate at a certain scale? So I think this is really important. And as I mentioned earlier, the threat is at an industry level, which is technology that's built by a collaboration across the industry that's largely monetized by a smaller set, and even arguably a set that's not contributing back to that project, creates a real threat for the industry. And this is the public cloud open source conundrum. It's been spoken about numerous times, and mostly it's in the context of licensing, and it's pretty interesting, especially if you're into open source licensing, to see what are the new, open source, air quotes, licenses that are being created to try to struggle with this and address this issue about the lack of parity across the industry. So of course our view is build it open, do it in the open, create an open ecosystem, and operate first. Maybe that's the 4th time I've said it, so I'm only got 3 to go. And here we're talking about the basic principles of open source. It's openness, it's upstream, there's freedom associated with it, and the notion that you could take this, really to not make it so economic and us versus them, to just think about what could we accomplish together. As we commoditize collective knowledge or democratize or whatever kind of buzzword you want to use for that, it allows us to tackle the next level set of challenges. So here we're talking about solving really interesting academic challenges that could have major impacts on humanity. So if we're doing that in a context where, well, first you got to build an operating system and then you got to, it just doesn't make sense. And we're at a point now where we have tons of infrastructure, and the next question is how can we operationalize that infrastructure? And so, I think thinking about it in terms of what could we do together collectively to build the broadest common base to then continue to innovate on top of is really where we're coming at it, the perspective that we're coming at it from. And that opens the door, proverbially, to all of these opportunities that I think in the case of what we're building together here with MOC and NERC and the academic endeavors, I think it's a really important and powerful set of possibilities that we're opening, the door that we're opening. And it's why we're spending time. I mean, you saw what we've committed in terms of our resources and our time and the importance that we see MOC playing as this cloud infrastructure that spans multiple organizations and helps us build better open source software, but also helps us create better academic outcomes. This is why we're so interested in it. And harnessing the SRE experience and turning that into automation to build these autonomic systems is something that I think we can actually achieve together. So that's why we're here, and that's why we're so excited about it. The core principles of our kind of world at Red Hat are on the open hybrid cloud piece. And what I've added here is just autonomous. And that is collecting data, driving models, re-architecting software so that it can be driven appropriately from closed loop remediation, This is the autonomous open hybrid cloud that we're trying to build, and it's something that I think we have an opportunity to do together at MOC. So this is kind of an internal pitch to our team saying, don't forget about the data, the telemetry, the monitoring, and the SRE. The knowledge that our SREs have needs to be encapsulated in code and committed into upstream community projects so that we can actually build these autonomous systems. Hugh totally talked about this, so I won't belabor it, other than it will be my 5th Operate First shout out. And as Hugh described, we have an internal mantra at Red Hat, which we call Upstream First. It's not unique to Red Hat in the sense that other parts of the open source community use this terminology, Upstream First. What's really critical is the idea that the broader community has vetted something and committed to it directionally before you're delivering it to end users. Operate First is taking that same idea. How can we get the community engaged in vetting and committing directionally to something that the community, who's best poised to understand how this software works, can agree that this is the best way to automate the operations of the software before it's ever put into broad scale use. And the opportunities, I think, are really interesting in terms of what CI/CD looks like. Again, something in the early days of MOC that we talked about a lot was how do we create different services that are given to users in controlled ways, A/B testing or canary testing or blue-green testing, that starts at the very beginning from a commit to an open source project, not much later, which is usually a production stage where you've already committed and maybe it was committed a couple of years ago. You've already committed the code and now you're just figuring out what's working best for your customers. So I think there's a lot of opportunity here, even in the academic research context of what it means to do large-scale software development, software engineering, and the implications of operationalizing software from a commit, which we usually talk about features. And if you look at projects like OpenStack or Kubernetes, there's a lot of features that are exposed with things like feature flags, and then this cruft that develops over time, which is technical debt, which is when do you decide it's just a standard feature? So we need to develop better maturity, really, at a software development level and understanding across the industry of how to do software development that delivers features that are operationalized for broad mass consumption. So this is the shout out here to MOC, and the things that we've done aren't focused in one specific area. It's helping communities build infrastructure that supports multidisciplinary activities. And I think that's kind of the cool magic of MOC. It's across universities. It's not focused just on computer science. And in there, we're operating this infrastructure. It needs to be reliable. It needs to be usable by researchers. And the kind of workforce development questions that came up earlier around data science, I think there's also an opportunity at an academic, at a level for schools to think in terms of site reliability engineering as a discipline, not the specifics of which tool do you use to run infrastructure, but the notions of how do you do broad instrumentation, telemetry, monitoring, what kind of remediation, feedback loops do you create, where do those go sideways, and you get wacky hysteresis, where there's a lot of interesting questions in there that I think we are ill-equipped across the industry to bring students out of universities into environments that are SRE focused. They're learning computer programming skills or maybe even data science skills, but not necessarily how to operate infrastructure, which is increasingly an important part of the ecosystem. So I think there's some interesting things that we're hoping to do within this community development around Operate First with the MOC that could go broader than just open source communities, but also start thinking in terms of how do we inspire students to invest their time in understanding these concepts. It's not just the tools, it's the concepts behind site reliability engineering. The heterogeneous computing that I mentioned before, really important, and probably one of the cooler things that we'll see at the MOC, because it's real, it's absolutely needed, and we get good collaboration across the industry with how we're collecting hardware within the MOC. And the hyperscale mentality is about consistency. So large blocks of consistent infrastructure. We need to build that same consistency while also providing heterogeneity, which is the challenge. And today, across most of the universities, you'll hear comments about our data scientists all have their own GPUs under their desks, but they're insufficient to do larger jobs, but we don't know how to pool them because then we don't have a way to schedule tasks on those GPUs. So, this kind of, how do you build heterogeneous computing environments that give researchers the tools that they need in a shared environment? That's exactly what we're trying to do with the MOC. It's a place where we can do this kind of innovation that has very direct impacts on the open source projects that are the infrastructure that is running the MOC. We've got some great examples of work we've done in Ceph and caching that very directly impacted the upstream community. And I think that's an opportunity we can exercise across all of the projects that we use to build the MOC. So, creating a more open environment and leveling this playing field for what could we build together to get to that next level of innovation, I think is the call to action here. And really, I think that's the core of what I wanted to talk about. It's an extension of Hugh's shout out to operate first, and the heterogeneous environment that's driven by modern demands, the distribution of compute alongside data, the applying the open source principles to building operational excellence and operational code so that we can create autonomous systems, supporting research that's both computer science focused as well as multidisciplinary on top of this infrastructure. We have a really unique opportunity here. So thank you for that opportunity. And I'm going to just cut it here and break to some Q&A. Thank you. I need volunteers for both the Q and the A. So that's why we have two mics.
Okay.
James. Yeah.
I'll give you a cue. You mentioned a lot of the problems we have with the closed silos, which is, getting inside them is really hard. And you mentioned some of the techniques about how people are trying to use different licenses to penetrate the barriers and make money about it. But another big problem about the closed cloud silos is data sovereignty. The Faustian bargain we've been making with Facebook and Google is we give you most of our data and you can play with it so long as you give us the services.
Yeah.
But in the future, once the cloud owns all your data, the cloud owns you. So data sovereignty, convincing people that they can actually control their own data and the cloud service provider doesn't have it, is actually going to be the key to expanding the user problems. I even start to believe that a lot of the security fears enterprise expresses is really about data sovereignty. So in your arsenal of tools, you mentioned bits and pieces about data. Data moving to the edge is a potential opportunity for data sovereignty. Yep. But what actual processes and things is Red Hat working on to help us in future try and solve the data sovereignty problem in a way that will actually be equal for all the users instead of just having one big player taking all your data and you having no say about it?
Blockchain. Next question? No, just kidding. And actually, I do think I'm making fun of blockchain because it's an easy target, because it has been a promise to solve many problems across the industry, and it's not always clear when people are thinking of it as just a distributed database, which is the wrong way to think about blockchain technology or distributed ledger technology. Could be applicable in this case, actually, I think. But one of the things that we've been doing is it's in partnership through research that we're doing with the MOC is looking at multi-party compute. And like the concept that your data doesn't have to move, but you could generate models, you could share information across the data is really important, powerful. And it fits directly to the data sovereignty issue. I'm invested in that because I'm a human who uses services where I'm giving my data away, which I don't really feel all that great about, but I'm not clear on what the alternatives are. So the ability to have clear control over how you share data is fundamental, and I think it's at a human level, it's kind of, we're being threatened. We're being threatened on a daily basis because we're being desensitized to giving our data away. Businesses know this because they show up on the front page of the Wall Street Journal and they hate that. But we're kind of being desensitized, and I think if you go generationally, you kind of wonder what happens with that. So whether it's direct control, I mean, I can imagine a world where you have revocation opportunities and you're getting popped up with all of these, can somebody access your data? And you're just going to keep saying yes. So that's probably not the answer. You need to have better control over the data. Maybe it's encrypted by you and it's, you know, some notion of homomorphic encryption that's the right tool. I mean, I think these are the areas that we're exploring. We don't have the right answers yet, but we know it's critical. From a Red Hat point of view, it's not our area of deep expertise, so we're mostly doing it in collaboration with others. But I agree with you that it's kind of a fundamental question, and the areas that I mentioned, a little bit of blockchain, mostly multi-party compute, a little bit of homomorphic encryption, those are the areas that we're dabbling in. Jeff?
Thanks. Jeff Rock, I'm the Dean of Engineering at Yale, and full disclosure, Hugh's brother. So I have a question that's maybe up a layer, but you mentioned workforce development, and what I see kind of at the university level planning around curriculum in computer science is a need expressed through student demand to meet kind of coding resource challenge. And so the students are coming in, we're getting alumni asking us to develop more basic courses, et cetera, et cetera. And I mean, this is natural enough, but the students who come in are looking to kind of land that big fish job on the West Coast when they graduate, et cetera. So I'm very interested in how we can kind of socialize and embrace, on behalf of computer science, but also on behalf of data science and mathematics, a kind of breakout level thinking about these larger research challenges as motivation for curriculum development in computer science, so that we can get away from the sort of instrumentalization of the curriculum that I think is currently underway.
So if I were to rephrase that to make sure I'm tracking what you're saying, Jeff, it sounds like a contrast between what I would call vocational
Exactly.
versus like more principled understanding of systems. And that's where that's exactly my view on what could we do in the SRE field, because I know, having tried this, you go to universities to talk about this, and they point you to a different institution who will do vocational training. Like, that's not the point at all. These are fundamental concepts, and what does it mean to create reliable operational software? Tools are important, but tools will change over time. It's the concepts that persist, and those are the things that we need to understand clearly. We could build models, and so I guess I'm agreeing with you. I don't have a great answer. I'm agreeing with you that and as an employer, recruiting students out of universities, the more specific the skill set is around, you know, there was a point in time where I was doing capstone projects with a university where all the students wanted to do it with Visual Basic, and I actually couldn't understand why. I thought that was insane, because no sane person would take that and go build real infrastructure level businesses out of a bunch of Visual Basic. But it was the tool that was being taught. And when I gave them opportunities to look at hard problems in operating systems, there wasn't a lot of interest. So I'm not sure what I'm not sure where the issue lies, but I do agree if we can focus on these fundamentals. Tools are a way to experiment with the fundamentals, and maybe it's expanding. It's not just about software programming. The flip side of the coin is you hear a lot, it's a phrase that I think is just weird, the citizen programmer, low code, no code, and that's basically saying, how can you make software development accessible to people who have no training in software development? And so there's a flip side, which is there's not enough software developers and people who understand computer systems in the industry to help address the industry requirements. So I don't know where, maybe we need a little bit of both, a stratified effort, which is some things are way more tactical and focused on the specific skills, and some are more fundamental, get back to the fundamentals. But I don't know, I'd love to work on that with you.
Just one follow-up. Do you think that the role of inviting industry onto campus to organize activities, I mean, hackathon is an overused term, but somehow to sort of bring the students into the discussion and give them problems or projects to work on, is an effective in your, I mean, it seems to be working here.
I've seen it be effective.
Yeah.
Now, the challenge is businesses are in business, and they tend to want students to solve their business problems, and that's a impedance mismatch. So the things that I think are really interesting is when it's the challenges are, to James's point about data sovereignty. The challenges are something you could feel directly as a human. Then I think it's more accessible to anybody.
So I have a question, but I'm not sure Jen will let me ask it. Do we have time? Oh, the last one. I'll let somebody else.
All right, sorry, Aaron. Hey, Chris. My question was about the autonomous portion of your talk, right? And about how the vision of autonomous clouds, I think it's very inspiring, and I think obviously I'm very interested in it. A lot of people are interested in it. And I think the data is actually the hardest part to standardize and get right across different environments, right? So the way that you use even open source projects, the way that you take those open source projects and you instrument your cloud and you instrument your hardware, you instrument your environments, it's very fragmented the way it's actually done today, even using open source tools, right? It can be done in a way that's totally incompatible. So what's your vision, even, imagining that we get something going in the MOC, we make the MOC an autonomous cloud, what's your vision of how you actually make that work across environments, given this telemetry being important?
We started simply being pragmatic. We thought, how about if we focus on Linux, OpenStack, and Ceph? Basically. 3 distinct projects with large-scale communities, each of which you have made fundamentally different decisions around what instrumentation looks like. And to be perfectly honest, we started with that pragmatic approach probably about 4 years ago, and we've made minimal progress. So it is a really hard problem. One of the things that's changed in the last few years is, I'm trying to not use buzzwords, but microservices software architectures are about building distributed systems. And distributed systems, turns out, are really hard. And one of the critical things that is important is instrumentation. How do you get insights into a large-scale distributed system? And because the Cloud Native Computing Foundation has created a ton of interest around microservices-based software architectures, focus on the Kubernetes project as a platform, but inclusive of a whole broad set of technology choices. There are larger communities that are more cross-community, that are focused at least on the monitoring and instrumentation level, which gives us now better levers to go to other communities and say, hey, if instead of doing your own bespoke tracing, what if you're open tracing compliant? And maybe just timing and coincidence, Prometheus has emerged as a pretty common tool for monitoring, for gathering metrics. So it may be a little bit of de facto standardization. Again, I'd stick with that focus on a few key projects that we know we're going to use and build at the MOC. And then that's just about getting data, cleaning data. If you're doing any kind of labeled approach, there's a whole set of data engineering tasks that come after we've collected data, and then there's model development and the data science that comes after we've kind of managed the data. So there's a number of steps. It's a big problem. It's why we need a larger community, and I couldn't agree more that a starting point is just how you collect the data, and I feel better today than I did 3 or 4 years ago, where we get into these just dumb arguments over technology choices that impede real progress. I feel like we're in a slightly better place today, and I would give a shout out to broader industry acceptance that instrumentation is fundamental, telemetry, insights, observability, there's all these new buzzwords that come up in that world, critical to building distributed systems. So. Done? All right. Thank you very much.